Good day and welcome everyone. I am here to showcase my e-poster research in the field of food science. My name is Nurul Izzah Nabila binti Muhammad Samsudin, and today I will be presenting on the isolation and purification of alpha-s1 casein from goat's milk using a HiTrap Sepharose fast flow cation exchange. Ladies and gentlemen, casein is a predominant protein that comprises 80% of the total protein content. The figure presented in this context showed casein consists of alpha-s1, alpha-s2, beta, and kappa. Alpha-s1 has been identified as a trigger for allergic reactions, particularly in individuals with cow's milk protein allergy, CMPA. Limited research has been conducted on alpha-s1 casein, prompting the need for studies due to its commercial unavailability. Alpha-s1 was isolated through acid precipitation and further purified using HiTrap Sepharose fast flow cation exchange (FFIEC). Our focus on goat's milk is attributed to its high homology with cow's milk. The objective of this study was to isolate and purify alpha-s1 casein from goat's milk using FFIEC. For sample collection, Sanen's goat's milk was aseptically collected, transported in an icebox, and stored at negative 20 degrees Celsius for subsequent analysis. The initial step in isolating casein from goat's milk involved heating at 36 degrees Celsius, followed by centrifugation to separate the fat layer. Following this, pH was modified, leading to a subsequent centrifugation process and washing before being subjected to another centrifugation to recover protein precipitate. The collected precipitate was subjected to freeze drying to facilitate its storage. In our study, we purified alpha-s1 casein from goat's milk using a systematic approach. The process began with the precipitation of two buffers, buffer A and buffer B, each serving specific functions in the isolation process. We reconstituted lyophilized casein in buffer A, adjusting pH and incorporating beta-mercaptoethanol. The mixture was then incubated in the dark for 1 hour before readjusting the pH. Then, the solution underwent dilution and filtration through a 0.22 micrometer membrane filter. Following that, purification was carried out using fast protein liquid chromatography (FPLC) with a HiTrap SV Sepharose column. The solution was injected into the column and fractions were eluted at 20%, 25%, 30%, and 35% of buffer B. Throughout the process, absorbance at 280 nanometer was monitored. Collected fractions based on observed peak underwent analysis using sodium dodecyl sulfate polyacrylate gel electrophoresis (FDS page. In Figure 4, lanes 3 to 6 reveal triple bands at 25 to 32 kilodalton corresponding to alpha-s1, alpha-s2, and beta casein. No bands aside from casein were detected in the SDS page. Figure 5a displays 4 prominent peaks eluted at 20% buffer B, exhibiting the highest UV absorbance at 280 nanometer. In Figure 5p, SDS page analysis of casein fractions collected from 4 measured peaks of ion exchange FPLC, indicating the presence of alpha-s1 casein at 24 to 26 kilodalton in lanes 2 to 5 loaded at 10 microgram per milliliter. In conclusion, our effective isolation and purification method for alpha-s1 casein in goat's milk was successfully carried out. Efficient isolation of goat's milk casein was accomplished, yielding a concentration of 545.96 grams per liter and a total soluble protein of 1.4 milligram per milliliter. The purified alpha-s1 casein exhibited a total protein concentration of 5.3 milligram per milliliter. To increase production, there is a need for optimization of the starting material. These findings provide a framework for acquiring highly pure alpha-s1 casein, setting the stage for its potential use as a standard protein in various scientific investigations, including studies on antigenicity and the development of a detection system. I acknowledge supervisor committees and financial support by UPM for a grant. Thank you for your attentive listening.